Hello, today we'll be going over the concept of binary classification, which is a part of classification and supervised learning. If you haven't already, I recommend you watch the videos on machine learning and supervised learning. So yeah, let's just get into it. So what exactly is binary learning? Or sorry, binary classification? Well, binary classification is a type of supervised machine learning where we basically classify the data into two categories or classes. And yeah, so whatever it is, we're gonna basically give it a yes or no to whatever the question is about the data. So, um, two possible categories or classes for the data. And obviously, binary comes from the idea of 0 or 1. This can also be like true or false, or positive or negative. So just know that we're dealing with, this kind of concept. So it's going to be one or the other. There's no in between. Um, and there are a bunch of, applications for binary classification. This can be, as I talked about in the previous video, like spam filtering. So is email spam or not? We can do it for diagnosis. Does the patient have a certain disease or not? It can also be for, um, let's say, sentiment analysis. And this is like, is this review for, let's say, like a restaurant positive or negative? So you can see here that's all spam or not, disease or not, positive or negative. It's that kind of concept of binary classification. Um, and yeah, there's a bunch of ways we can, or algorithms we can use for binary classification. So I won't go into depth what each of them are, but I'll just explain briefly. So first we have logistic regression, which is a very common form for binary classification. I know I mentioned this before in a previous video, but just to recap, despite being called regression, it's actually used for classification, and that's because the shape of the graph kind of helps you determine if this is yes or no, or one category of the other. So, yeah, uh, not for regression. So decision trees. Um, this is basically splitting into several, kind of like a tree where you're going to be constantly asking yes or no, for if then rules. And yeah, you're basically going to keep branching off based on the features given in the data so that, for whatever data you get, you can kind of categorize it based on every single feature. So branching into a series of if then. A random forest is basically it's an application of decision trees. It basically uses multiple decision trees. It's like generates multiple DTs, and kind of randomizes them and then takes accounts for all of the results of each decision tree to make a decision. So it's an ensemble method, multiple DTs, and DT is just decision trees. And yeah, so it's generally a lot more accurate than decision trees. There are also neural networks that can be used for binary classification, and yeah, they use neurons to, or neural layers, layers to, um, learn patterns in the data and determine if this is one type or the other type. And obviously you can use all of these, or you can use like the bottom three for other applications outside of binary classification, but they are also used for binary classification. And yeah, I guess I can talk about, so how do we know if, let's say our algorithm for binary classification is doing a good job? So how to test the accuracy, or how to test how well our binary classification is doing. Well, there are several different ways. We can look at the accuracy. It's just simply the number of correct to total. And yeah, it's just simple, let's say like percentage. Precision is the number of true positives among all positives. So unlike accuracy, after we've categorized everything as, let's say, 0, 1, or true or false, we look at the number of true within, the truths. And this can be like, let's say we're classifying spam, we filtered out all the non-spam emails, and among those we count how many are actually not spam. So if we categorize 5 as not spam, and only 3 of them were actually not spam, the other 2 are spam, then that's basically 3 out of 5, or 0.6 precision. We can look at recall, and this is just the proportion of true positive predictions among all actual positive predictions. So what does this mean? Basically, it looks like, okay, so this might be a little bit confusing, but yeah, let me actually write it down. Among all So, previously we looked at the number of true positives among the number of positives that we predicted, whereas recall is the number of true positives over all actual positives. So, let's say, previous example, we said that out of the 5 we predicted positive, only 3 were actually positive. So, we got 3 true positives, and then let's say there were 10 total emails, and among the 5 we categorized as spam. Let's say 2 of them, or sorry, yeah, let's say 2 of them were actually not spam. So that means 3 plus 2 is 5 actual positives, but we only got 3 of them, so same as precision, we're going to get 0.6, or 3 to 5. And yeah, there's also something called F1 score, which is basically the mean of precision and recall. And yeah, obviously there are a bunch of other ways we can evaluate metrics for evaluation of how well our binary classification is doing. But yeah, these are a few of the common ways. So as always, we'll talk about some pros and cons. So for pros, what do we have? So the pros of binary classification is it's, I guess, simple to understand. And it has basically a very straightforward decision boundary. It's either going to be yes or no, 0 or 1, or true or false. So simple decision boundary. It's also generally efficient, more efficient than multi-class classification. obviously, because we're going to only have 2 categories rather than a bunch of categories we may have to consider. And so this means that faster to train and make predictions. There are also a bunch of applications for this. As we talked about here, there are just a bunch of applications for binary classification. There are also clear evaluation metrics, which are what we talked about here. We can basically, in other words, check how well our model's doing very quickly and clearly. And yeah, however, there are also cons. So I guess there's always a problem of oversimplification, where you're basically categorizing everything into just 2 classes, and that can oversimplify complex problems that don't naturally have only 2 categories. And obviously, similar to the point above, we're limited to 2 classes. Like, if we're categorizing species, we can't account for, all the different types of species. We have to categorize them into 2 classes. And there's also feature importance. So when we're doing binary classification, we might have a bunch of different types of features, but generally not all of the classification methods we use provide us the feature importance. So which features or input variables are, let's say, more important or less important than others. So if we're looking at spam or not spam for emails, there might be like who it's from, how long the email is, the content of the email, but it might for some reason it might focus on just the length of the email, but we don't really have a way of knowing that if we're using, let's say, something like a neural network. There's also bias issues where obviously this is applicable to everything, but if the training data is biased, this kind of binary classification model can kind of amplify this bias. And those are just some, I guess, pros and cons of binary classification. And yeah, in the future I'll be making more videos about concepts we talk about in this video. But other than that, thank you for watching.